Hi everyone. Today I'm going to talk about the periodic table. The periodic table is something that you will have access to during all of your exams, quizzes, homework. You're always going to have access to a periodic table. Unless your instructor is testing you on like the names on the periodic table, you might get a blank one. But for the rest of your class, you're going to have access to a periodic table. And the periodic table is your cheat sheet to so many things. If you understand things on the periodic table, there it saves you from memorizing a lot of things. Okay, so let's get started. Okay, so I have the periodic table here in front of us, and you'll see I have written there that your groups on your periodic table go down the periodic table. So your groups are your 1A going down, your 2A going down, your 3A, 4A, 5A, 6A, 7A, and 8A. We don't really deal with these numbers up here on the periodic table. Okay, those are a newer method of looking at the numbers, and we just don't use those. Likewise, we don't use these numbers down here. Okay, so I would be surprised if your instructor ever refers to those other numbers. So your groups are 1A, 2A, 3A, 4A, 5A, 6A, 7A, 8A. Okay, and so as you're going down the periodic table, the group tends to have similar chemical properties. Lithium here has similar chemical properties to sodium, which are similar to potassium, which are similar to rubidium, and so on. Okay, so your groups on the periodic table going down tend to have similar chemical properties. Your periods go across on the periodic table. Okay, and this is period 1, 2, 3, 4, 5, 6, 7. Okay, those are your periods. And you'll hear us refer to your group and your period fairly often. So realize groups go down, periods go across. And periods do not have chemical properties in common. Okay, so those are your groups and your periods. Okay, now I'm going to talk about some groups on the periodic table that you need to know. 5 groups and 2 periods. Okay, so first, group number 1A here is your alkali metals, and group 2A is your alkaline earth metals. The way I remember that is if you ignore the word metals, alkali has one word and it's group 1, alkaline earth has 2 words and that is group 2. Over on this side, group 8, these are your noble gases. Okay, these are the nobility, those are the king, and everybody wants to be like the king. When we start talking about charges and gaining and losing electrons, it all has to do with wanting to be like a noble gas. Okay, group 7A here is your halogens, and group 6A is your chalcogens. Most instructors will not need you to remember the chalcogens, but some instructors do require that. So I've got it on here. Okay, so we've got the alkali metals, group 1, alkaline earth metals, group 2, your chalcogens, group 6, halogens, group 7, noble gases, group 8. Okay, you will absolutely need to know your group 1, 2, 7, and 8 for sure. Okay, now down here we have these 2 periods. These are called the lanthanides and the actinides. So what I want you to notice here on the periodic table is this is number 58, 57 is here, and 72 is here. We've got over here, we've got the number 71. So this whole area right there, that whole thing goes right there in between those two. Okay, and he's lanthium, so the period right after him, those are the lanthanides. Okay, here you'll notice I have number 89 and 104. Here's 90 to 103. That whole area there goes right in here between those two. Okay, I'm going to show you what that looks like if the periodic table was put together like it should be. Okay, so I cut and pasted a periodic table here. So if we had the lanthanides and the actinides where they belong on the periodic table, where we're going in numerical order, you'll see that that whole area that's at the bottom of the periodic table fits into the middle of the periodic table there. But because most of those are man-made chemicals, they don't occur very naturally on our planet, they're not very stable, we don't really deal with those very often. So we take that group out and move it down so we can fit it all on one piece of paper. And here's 3 more areas of the periodic table that you need to know. So the ones that I have in blue here, okay, these that are outlined in blue, okay, those are your representative or your main group elements. Those are the periods 1 through 8 that I had talked about. Those are the ones that we're looking at a lot. Those are your representative, your main group elements. Okay, the ones in green here are your transition metals. Okay, they're all metals, they're transition metals. Okay, those are your transition metals. I kind of think they're in the middle, they're in transition there. And then down here on the bottom, those ones that go in here, right in here, okay, those are your inner transition metals. They're like inside the transition metals. 3 more areas you need to know on the periodic table. You will notice some of you get a periodic table that you have this stair step right here. Okay, that a stair step goes down your periodic table here. That's the split between your metals and your nonmetals. Everything on the right-hand side of that, outlined in red, is a nonmetal, including hydrogen. Hydrogen is also a nonmetal. Everything to the left of that stair step, except hydrogen, is a metal, including all of those down there that go in the middle right here. Okay, those are all metals. And then the ones that I have the lines of blue through them, those are your metalloids, your semi-metals. They're kind of like metals, they're kind of like non-metals. They're metalloids. And I just remember I start at boron and I have 1, 1, and then I straddle the line, 2, 2, and then 1. So somehow to remember those are your metalloids, your semi-metals, okay? Another area of the periodic table that you need to know are your diatomics. So these are elements that they never hang out as one atom. They never travel alone. They always travel in pairs. Okay, and the rule is that you start at number 7, nitrogen. You make a 7. So you come down here and you make a 7. Okay, don't come down at oxygen because that makes more like a 1. So make a 7, and with hydrogen, there are 7 of them. Okay, so your diatomics, 2 of them. So they always travel in pairs. So you get H2, N2, O2, F2, Cl2, Br2, and I2. Okay? They never hang out alone. So we're never going to say, when I say hydrogen, we're going to write H2. Okay? H plus with a positive charge on it, that will hang out alone. That's totally fine being alone. The hydrogen ion can be alone. Or let's say that I have hydrogen on something like this. Okay, he's not alone. So you don't need 2 of them. Okay, it's only when hydrogen is all by himself as an H, you're going to put a 2 on it. Okay, same with nitrogen, oxygen, fluorine, chlorine, bromine, and iodine. Okay, so those are 7 diatomics. Start at 7, make a 7, and with hydrogen, there are 1, 2, 3, 4, 5, 6, 7 of them. Okay, 4 more areas on the periodic table that you need to do are what we call the blocks. So this is my, oh, let me get my color going up here. So these are blocks. Okay, this is our S block in red here. And for this, helium, which is typically over here, he actually belongs over here. Helium is in the S block. Okay, over here in green is your P block over here on the right. The middle there, those transition metals, that is your D block. And on the bottom, the inner transition metals, that is your F block. Okay, so I was taught to remember this by Sir, please don't fail me. Okay, and what you want to recognize is it's by height. So the higher it is, you've got the S over here, then you get a little bit lower, your P, a little bit lower, your D, and then all the way at the bottom, you got your F. So S, P, D, and F. Okay, so one of the other things on the periodic table that we're going to be able to tell is we're going to know how many protons an atom has, how many electrons an atom has, and how many neutrons an atom has, just from the periodic table. Okay, so we're going to be saying that protons, we're going to label those as P plus, neutrons are just an N, and electrons are an E minus. Protons have a positive charge, that's why we put a plus on them. Electrons have a negative charge, that's why we put a negative on them. And neutrons are neutral. Okay, so when we look at an element on the periodic table, okay, I'm going to grab calcium. Okay, so when you look at calcium on the periodic table, he has a 20 up here and a 40.08 down here. Okay, sometimes you'll see a symbol written as this. It's written the opposite of how it's written on the periodic table. The larger number is on top and has no decimal places on it. I'll talk about that in a second. Okay, well, up here, this is your number of protons and your electrons in a neutral atom. Okay, so if it's neutral, it has no charge. So it means you have the same number of positive and negative. Your protons and electrons are the same in a neutral atom. Okay, down here, this is your mass. And your mass is your protons plus your neutrons. You add your number of protons and your number of neutrons, that is your mass. Each of them weighs one atomic mass unit. We call it AMU. Okay, electrons weigh 0 AMU. I mean, they do have a mass, but in comparison, it is so small that we don't count it. It would be like if you weighed yourself and then you weighed yourself with a penny in your pocket, the penny is not going to make a difference compared to your mass. So electrons in the scheme of things have no mass at all. Protons weigh 1, neutrons weigh 1. So your protons plus your neutrons is the mass of your element, okay? And you'll notice that this has a decimal in it. Okay, so how can I have 0.08 of a proton or a neutron? Okay, this on the periodic table, that's your average atomic mass. Okay, and we'll talk about that in another video as far as like isotopes have different numbers of neutrons, so they have different masses, and then we average all of the percentages of this with this many neutrons and that one with that many neutrons, and we come up with an average mass for them. Okay, so on your periodic table, it's an average mass. If you're looking at just this, that is the mass that you're looking at. I could have said calcium 3920. This one would have a different number of neutrons. Still has 20 protons, but a different number of neutrons. Okay, so one of the things to recognize is your protons on the periodic table. Those are like your soul. You cannot change who you are, okay? That is who you are. That is your number of protons, okay? Carbon has 6 protons. He's number 6 on the periodic table. If carbon gained a proton, he would be number 7, and now he would be nitrogen. He wouldn't even be carbon anymore. Okay, so your protons are like your soul. You can't change that. You are who you are. You can't change it. Okay, your neutrons, they're like your weight. Okay, you can gain weight and lose weight, and you still look like you. Okay, it doesn't matter how heavy or light, you still look like you. Okay, that can change as much as it wants to change. It just changes your mass. Okay, your electrons, on the other hand, those are like your clothing. Okay, you can dress up like the king and look like the king. You can dress down like the pauper and look like the pauper. Okay, and look entirely different. You can masquerade as something entirely different. Okay, so this is a masquerade. Okay, you can be something entirely different by changing your number of electrons. And that's what we mean by if it has a charge. Okay, if it's got a charge, it has a different number of electrons than it has of protons. Okay, so that's kind of how an atom is made up, how you can tell by the periodic table how many protons and electrons an atom has, and what your mass is. Okay, so now we're going to look at kind of the makeup of an atom. So right in the middle of the atom is the nucleus. Okay, we have our nucleus here. And inside of the nucleus is your protons and your neutrons. And in this case right here, I'm looking at beryllium. Beryllium that weighs 9 and has 4 protons. So I have 5 neutrons in there and 4 protons, okay? And the neutral atom, since he's got 4 protons, he also has 4 electrons. The electrons orbit out here kind of like moons around that nucleus. Those negative charges are attracted to the positive charges in the nucleus. Okay, so the electrons just orbit around the outside. Now this is the Bohr model of the atom, that the electrons are kind of orbiting on the outside. You're going to find out later that 2 of those electrons are actually in a different orbit. But right now we're just going to go very, very simple with they orbit around the nucleus. Okay. So right now I have 4 protons and 4 electrons. And so I'm neutral. I have no charge on that atom. Okay. But what if I were to get rid of one of those electrons? Now I've got 4 protons and 3 electrons, which means I have a 1 positive charge. Okay, more protons than electrons. So if you lose an electron, you lose a negative, you gain a positive. Okay, more protons than electrons. If I lose another electron, now I've got 4 protons still, but now I've got 2 electrons. Now I've got a positive 2 charge. Okay, so what if he gained an electron? Okay, you would have 4 protons, but now you would have 5 electrons. You would have a 1 negative charge. Okay, 1 more electron than protons. Okay, so now we're going to pop over to the periodic table. I'm going to show you how to tell on the periodic table what the charge is going to be, how many electrons it's going to gain or lose. Remember, it does not gain or lose protons. It only gains or loses electrons. Okay, so remember earlier when I said that everybody wants to be like a noble gas, they want to be like nobility, they want to be the king. They want to have the same number of electrons as a noble gas because then they can masquerade as the king. Okay, so you see fluorine here has 9 protons and 9 electrons as a neutral atom. 9 protons and 9 electrons. But now if he gains an electron, now he's going to look like neon. He's got 9 protons and 10 electrons. So he has 10 electrons just like neon. So he's masquerading as the king. He looks like neon. Okay. And so that's going to have a -1 charge. Right? When you add those together, he's got a -1 charge. Okay, well, what I want you to notice is that all of them, chlorine needs 1 more electron, bromine 1 more electron, iodine 1 more electron. So that whole group there is going to be -1 when they gain and lose electrons and form ions. So ions lost or gained electrons. I don't know what's going on with that. Okay. So they're all going to gain 1 electron and have a 1 negative charge. Oxygen here has 8 electrons, so he needs to gain 2 to look like neon, so he would have a negative 2 charge. Same with sulfur, same with selenium. They're all going to gain a negative 2. Okay, so right now I'm going to go ahead and put in my line here for my metals versus nonmetals. Okay, because something we need to recognize is that metals always lose electrons and will be positive charged. Nonmetals gain electrons and will have negative charges, okay? So looking at your line here, remember your nonmetals are on the right. They're going to have negative charges. They're going to gain electrons, okay? So if I look at number 7 here, nitrogen, he needs 3 electrons to look just like neon. So he's going to have a negative 3 charge. He's going to gain 3 electrons. Same with phosphorus, same with arsenic, okay? We're not going to go down here to antimony because antimony is a metal, and he is going to lose electrons. He's going to be positively charged, okay? Okay, and our tellurium down here is also going to be the negative 2, just like oxygen. Okay, so now I'm going to pop over to this side of the periodic table. Okay, so if we look at lithium here, he's got 3 electrons. Okay, so in order for him to be perfect, like neon, he would have to gain 7 electrons. Well, a positive 3 is never going to be able to hang on to a negative 10. They're not going to be able to attract that many electrons, okay? So instead, lithium is going to lose an electron to come up here and look like helium, okay? They're going to go to the closest noble gas. The closest noble gas to lithium is the one before him, which is helium. So lithium would have 3 protons and only 2 electrons because he would lose an electron. So that would have a positive 1 charge. Okay? Hydrogen will lose 1. Sodium will lose 1. Potassium will lose 1. All of them will lose 1. They will all be positive 1. That whole group is positive 1. Okay? If we look at beryllium here, it's the same thing here. Those 4 protons are never going to be able to hang on to 10 electrons. Okay, just not enough positive charge to attract that much negative. So instead, beryllium is going to lose 2 electrons to again come over here and have 2 like helium. So he's going to have 4 protons and 2 electrons. He's going to be a positive 2, 2 more positive charges. That whole group is positive 2. Okay. Boron here. Boron has 5 instead of gaining to get 10. Okay, so he can't gain 5 more. Instead, he's going to lose 3 to look like helium. He's going to have 5 protons and 2 electrons. He will be a positive 3. This whole group, positive 3. All of them. Aluminum, gallium, indium. Okay. Now, there are a couple of things, okay? So those have absolutely, you can tell by the periodic table what the charges of your main group elements are. And then real quick here, let me erase some stuff here to look at carbon, that carbon group. Okay, so the group of carbon gets a little bit wonky because carbon could either, he can go either direction. He's got 6, he could either gain 4 to look like neon, or he could lose 4 to look like helium. Okay, you could go either way. So we say that group tends to be +4 or -4. Okay, but it would really only be those 2 because we know the germanium is going to be a positive charge. He's a metal. Okay, so we don't really worry about group 4 and what their charges are going to be. Okay, what we do want to remember is group 1 is +1, group 2 is +2, group 3 is +3, Group 5 is -3. Group 6 is -2. And group 7 is -1. Okay, and we don't really worry too much about that group there. But if we did, from the right would be -1, -2, -3, either +4 or -4, and then +3, +2, +1. Okay, so that's how you can tell from the periodic table what your charges are on those elements, your primary elements, your main group elements, the representatives. Okay, so down here in the middle, let me change my color. These guys in the middle here, these transition metals, these are variable charges. Okay. You will either know from the name what the charge is, or somehow we're going to tell you. Somehow you are going to know from the name or the formula, you're going to know what the charge on those are. Okay, same with these down here. These are also variable charges. They can have more than one possible charge. Okay, so the transition metals and the inner transition metals, except, okay, there are five things on here that you're going to need to know. Okay, so remember, I said that tin and lead, that these guys right here down here, okay, they're metals. Okay, well, we know that these two right here, and you're likely going to need to memorize these two right here can be a +2 or a +4. Okay, so you're going to find out from the name or the formula or something, you're going to find out what the charge is on those. Okay, these two right here are always +2. And this one right here, silver, is always +1. Okay, those are the 5 that you really kind of have to remember, that those 3, zinc, cadmium, and silver in the variable charges are not variable. Okay, and the tin and lead over in the non-variable charges are variable. Okay, so those are 5 that you need to remember. And the way I remember that these are +2 and +1 is we know that's +3. Those are all +3. So if I look at that, that's like a little staircase there. Those 3 are +3, those 2 are +2, and that 1 is +1. Okay. So that's how you're going to know from the periodic table what your charge on your ion is, whether it gained electrons or lost electrons, and how many electrons it's going to gain or lose. And if you watch my video on polyatomic ions, how to memorize your polyatomic ions, I go a little bit deeper into the charges and knowing the charges, and if it's got oxygens on it, like one of your polyatomics being SO4, it's also a -2, just like sulfur on the periodic table is a -2. And I talk about that in a little bit more detail in my polyatomic ion video. Okay, so there's 2 more things we need to talk about on the periodic table. Okay, and one of them is the atomic radius, the size of the atom, right? So the atoms are a sphere, so the radius is how big across, how wide across it. Sorry, halfway across it. Okay, so the radius is the size of the atom. And the rule is on the periodic table, it gets larger as you go to the left, and it gets larger as you go down. Okay, so up here, I didn't really go into this. I had talked about the Bohr model of the atom. Okay, so if this is my nucleus and these are my electrons around the outside, they don't all orbit in one orbital. They orbit in several orbitals. Okay, and you're going to learn there are different shapes to the orbitals. Some of them are shaped like this. Okay, so they have different orbits. They're not all just in that one orbital. Okay, so as we move down the periodic table, as we're going down, we're building more electrons out on the atom, right? So here's our nucleus, electrons, electrons, right? So it makes sense that the atom gets larger as you go down the periodic table because you're adding more layers of electrons, like you're adding to an onion, okay? So now going to the left on the periodic table, you might feel like, well, as I go right, I add more electrons, so I should get larger. But as you go right, you add more protons as well as electrons. Okay, so as you get more protons, those protons in the inside pull the electrons closer to the nucleus. So as you go to the right and get more protons, because they're all in the same orbit, they just get pulled tighter in. So it's actually smaller as you go to the right. As you go to the left, less protons, less pulling those electrons into the inside. Okay. So your atomic radius gets larger as you go left and down on the periodic table. Francium is your largest atom on the periodic table. Okay. All right. So the other thing is the atomic radius and, oh, no, the electronegativity. Sorry. So there's three terms that we use. They all pretty much mean the same thing, and they have the same trend. It is exactly the opposite of atomic size. Okay, this one gets larger as you go up and larger as you go to the right. Okay, and these are called electronegativity, which is how much of an ability does it have to attract an electron. Ionization energy, which is the energy required to remove an electron. An electron affinity, which is the energy released when the electron is added. So basically, it's kind of like how much affinity does it have for an electron? As you add electrons, as you release energy, it's more stable. So as you release energy, the more energy you release, the more stable it is, the more it wants that electron, the more affinity it has for an electron. Okay, so these are all three essentially the same thing. How bad does it want an electron? How likely is it to get an electron? Okay, and the trend is our noble gases don't count because remember, noble gases are perfect. Their nobility, they're already perfect. They don't want to gain or lose electrons. Okay, okay, so fluorine is your most electronegative atom, highest ionization energy, highest electron affinity. Okay. And it makes sense because this whole group here, fluorine, chlorine, bromine, iodine, all of those halogens there, they all want one electron. They're more likely to want the electron than oxygen is to want the electron because they're closer to perfect. Okay, so they're more likely to want the electron worse. They are going to require more energy to remove an electron because they don't want to give up an electron. Okay, and it's more electronegative than the chlorine is because those electrons are closer to the nucleus, closer to the protons. Okay, so they're closer to the protons up top, closer to protons, so more likely to gain an electron. Okay, and as you go to the right, they're closer to perfect. Okay, and you guys are going to learn very soon that closer to perfect means that they are going to have an octet. They're going to have 8 electrons in that valence shell, that outside orbital. Okay, so those are the other two things on the periodic table. Is our atomic radius, the size of the atom gets larger as you go left and down, and the electronegativity, ionization energy, electron affinity, they get larger as you go up and to the right. Okay, so I believe that's all I have to say about the periodic table today. So have a great day.